Hello, hello, everyone.
Hey,
Welcome back.
everybody!
This is like our episode. Is this episode 3 of Deep Learning, Andrew?
Episode 3!
Yeah. I'm very excited. So thank you for joining us. Hello, Nezagrev. Hello, Whiter's Meteor. Hello, Terra Nemi. Special hello to you. We're here to talk deep learning, and our today's topic is a ode to behavior trees. So thank you for joining us. My name's Aurora Walker.
My name's Andrew McLean.
We're here to talk deep learning. So it's our deep dive topic Twitch show on Battlesnake related content, especially educational content, stuff we can like dive into and is like a little meaty, and we can maybe spend a little time exploring and enjoying together, and maybe learn something along the way. Hey?
It's going to be a great time. I am learning things, so if I am learning things, then y'all are probably learning things too.
Yeah, absolutely. Andrew, would you mind telling everyone about the fine organizations that help us run these Twitch streams?
Oh man, would I? So not only is this Twitch stream, but all of our other Twitch streams and the Spring League, in fact, made possible thanks to the support of our amazing partners, RBC, AWS, GitHub, and Replit. And you can see their links down on the corner down there. If you want to find out more information, you can go to Spring League, our Spring League page on the website. There's links right there, or you can just Google them. There you go. So you can go to that link that Aurora just put up on the screen, and you can find out more information about them. They're pretty awesome. They're hanging around. RBC has a snake AWS has a snake in the league right now, right?
Yeah, they totally do. They've got a little bit of a team running for sure.
Awesome. So definitely check out some more information on them, and huge thank you to all of those amazing organizations for helping make things like deep learning and coding badly and SPL and Spring League possible.
Absolutely. Awesome. And of course, deep learning right now, Andrew and I are picking topics, stuff that interests us, stuff that we enjoy. But if you are interested in something for us to deep dive on deep learning, or maybe you have some deep learning knowledge you'd like to share, hop onto Discord. Andrew and I are both there all the time. There's a deep learning channel. Let us know. Feel free to give suggestions. And if you've got ideas or things you really want us to talk about, that's a perfect place and a perfect way to let us know. Yeah. So today's topics, decision trees. I was kind of into this because last time, if you joined us, we did a deep dive on the Niederschnake research paper, which heavily uses behavior trees. And in a behavior tree, we're looking at all of the possible game state boards, right? Like what happens if your snake goes left or right, and just like building a giant tree of all of the possibilities. And then the real challenge and the art and the beauty of building a Battlesnake that way is coming up with pruning strategies and how far can you look ahead, because that tree gets really, really huge. So I wanted to touch on decision trees, which are a little bit different. Decision trees are, to put it simply, they're a little bit more like if statements, like checking states and options. And I wanted to talk about these because I think a lot of people build decision trees by accident without realize they're doing it. And imagine how much tidier and organized and easier your code could be to deal with if you did it on purpose, like, right? I don't know. How would you've been working, you've worked on a snake, right, Andrew? How would you think you'd classify it as a decision tree type snake?
Let's say yes. Nobody go digging into my code. Please, nobody go try and figure out which snake is mine, because it does make a decision. But it does not use a decision tree. Its decision is a very simple one. We can recreate what it might have looked like. But Toby Flender's snake is doing well, but he has a single strategy, which he takes all the time, which you may or may not have seen.
You're Toby Flender. Do the casters know that? Because I think you're in one of the casters' their pools, hey?
I am. I'm in Aileen's pool, and no, I don't know what she knows. I also have another office-themed Battlesnake that may make it into the league, but has not been created. So maybe it'll be my decision tree snake. It's I gotta find the name. I can't remember what it is, but it's something very clever. I promise.
That's brilliant. That's brilliant. So, I mean, I think decision trees, let's give them some formal love. Let's talk about them in maybe sort of the more formal terminology that's out there. And I thought another thing that could be fun is let's build together. Let's build a decision tree for some strategies. And I was thinking constrictor mode, because I feel like constrictor mode doesn't get enough love.
I love constrictor mode. It's my favorite mode of all the modes. It is the constrictor mode is my favorite.
Yeah. So let's, and we would appreciate feedback, chat. Don't feel shy. Help us move through this. I've never built a formal a decision tree before. Like I've done it like kind of sloppily, but I'm going to try really hard to use the correct terminology and the correct like rule set for building them and see what we get. How does that sound? Cool. Awesome. All right. So I'm just going to swap over. Oh, there's Andrew. We lost you for
I'm here.
Friend.
Oh, God. I dropped down to 720p, so now when I talk, my mouth matches up. Because who needs to see this face?
No, we love your face.
Nobody.
And Kerrigan, so far outside of my wheelhouse, you don't know how much you'll help. No. So you don't understand. We are learning together, my friend. Deep learning is not about Andrew and I like showing off our egos. No. You misunderstand, friend. We're going to go through this together. So I'm going to start with an example. I did a little advanced work here. And I'm going to use an example. So pretend this is actually like I have a basic strats snake that I use for training and tutorials, and basic strats moves randomly. And I realized I could draw it as a decision tree, and I did that to kind of like practice a little bit. And then I realized that the basic strats snake, which just like moves randomly and tries to avoid hitting obvious obstacles, also perfectly demonstrates all the foundational elements in a decision tree. So let's do some terminology. So I think you folks can see this okay. Let's see here. Yeah. So when it comes to building a decision tree, there's sort of like two components to it. So there's the main, I'm going to call them control nodes. That's a term that's used a lot that control how you're going to move through the tree. So when your program starts, you're going to kind of start at the root, and then you're going to move through this tree making decisions and doing actions depending on what happens. So there are two main kinds of control nodes, and a lot of the research I read uses, I think it's like based off of a Unity library. So maybe a good context is decision trees are very commonly used in game AIs, but for games like Halo and like BioShock to control like the NPCs. So that's like you use a decision tree to be like, patrol hallway, open door. If you see the player character, like raise the alarm. So it's like decision trees that control their behavior and get them to like move around. So they have like a script, right? The decision tree provides a script and provides them with actions to try and how to kind of proceed through that. So like that's the type of game you typically see this structure in. And if I'm going to be completely honest with you, I have no idea how performant this would be. This strategy might be a little slow for Battlesnake. But having said that, though, I think a lot of people end up building something like this with their kind of rule-based snakes. So I think it's interesting to kind of diagram it out and like think about it deliberately.
I actually like this better too, because I feel like if you're a new Battlesnake developer and you look at Battlesnake and you're like looking at a lot of the snakes that are out there, it's hard to figure out how the strategy works because a lot of them are using some really great AI. This is something that you can do without needing to really worry about the kind of formal AI, minimax, that kind of stuff.
Totally. So to provide like a consistent language to talk about it, there's in our tree. So using Battlesnake as an example, using this random one, there's two main things. So the control nodes control how you go through. So in this case, the top node here, random move, that's like a top control node. And there are two main, like most commonly implemented control nodes. One is called a sequence, or sorry, a selector. Let's go with one at the top. So with the selector, I'm saying random move. In Battlesnake, you have 4 directions you can go. You can go left, right, you can go up or down. And Selector is specific in that only one of these needs to work. So you kind of run through them until one of them succeeds. And traditionally with a selector, and probably most like libraries that implement decision trees for you, it'll go from left to right. So in this case, it would be like left, does left succeed? No. Okay. Does right succeed? No. Does up succeed? Yes. Okay. I'm done. And so it just goes to whatever the first success is. Having said that though, like, theoretically, academically speaking, you could also have a selector that did it randomly. And Andrew, I don't know about you, but I wasn't planning to write code today. Did you want to code this up today?
Let's say no, but we'll see where we get to. We will see where we get to.
So with deep learning, we're very like academic theory focused, right? So we're just going to write stuff on paper and it's going to be real. And we'll worry about implementation details like later, right?
There's like multiple reasons for this, mostly because I can't actually program, as you would see if you looked at Toby Blendersnake. So this is good for me. This is a good level.
Totally. So I was reading about this. So there are other ways you can kind of choose which nodes. So like left to right, doing them in order and having the first, like hitting the first one that succeeds, like just keeping going until one of them succeeds is kind of like the classic selector control node. But like in theory, you could have ones that were random, like it just randomly did that. So for our demonstration for Randosnake, I'm like randomly pick one until you get a success. Although I know from having written code like this is that it might, sometimes random means like, can I go right? No. Have you thought about right? No. What about right? And like randomly, I could just keep picking choices you've already eliminated. So maybe sequential would be better and like kind of just run through them in order. But I've written this one as random. In theory, you could also do a loop, like you could just keep looping. That's another potential option, or even maybe doing them concurrently. So like exploring all of them simultaneously. I think these are all possible options kind of to tuck away in our toolkit. But at the high level, selector means that the child node, so in this case, left, right, up, and down, one of them has to succeed.
Just so you know, there's some important things in the chat right now. I haven't seen them.
What about right?
Thank you, chat. For demonstrating our issues.
Yeah, like this is like programming is the art of telling a computer what to do, and you have to say it very precisely. So like, novel idea, go right. I mean, maybe. I just don't think we've really considered right. Give it a go. So at any rate, awesome. So selector, have one of them succeed. That's kind of like the top example. So if we were building a behavior tree for just random move, right is the right move. We would just need one of these to succeed. So the next step, so let's say we actually picked right. Let's commit Twitch. Let's commit to right. And I've only drawn it out once for left, so I'm sorry. But all of the options have the same sort of choices. And this gives us our second control node type. So our first control node, selector, one of them needs to succeed to kind of keep proceeding. In a sequence control node, which is this next group, what's special about a sequence is that all of them need to succeed in order for like success to be passed up the chain. So in this case, in order to successfully go left or right or go in any direction, first you have to say like, hey, is there a wall? Am I going to run into myself? Like, is left going to put me into myself? Is left going to put me into the path of another Battlesnake? And then kind of go left. So these are sort of like sequences. They all need to be true in order for true to be passed up the line. So we're not just looking for one of them. This diagram represents 90% of the logic my snake has. Yeah, this is like basic strats. But now there's a formal diagram, which makes it feel grandiose. I don't know. So down at the bottom here, this is where we get our leaf nodes. So now we're no longer in control nodes, but leaf nodes are like literally what's going to happen. So they're typically going to be either a conditional check. So like, is it a wall? That's a yes, no, Boolean conditional check. Same thing with like, is my next move going to run into myself or in others? So those are one type of leaf node that we can have. And the second type of leaf node we can have is an action. In this case, the action is to go left. So if we were going to talk through this diagram through scenarios, we can imagine, okay, random move, let's randomly select left. Maybe I look at the wall and we say, is there no wall? Yes, good. It's not going to run into myself? Yes, good. It's not going to run into someone else? Awesome. Go left, action. And then in each of those cases, the leaf nodes are going to pass success back up the line. And then the whole L selector up here is going to return success up to random move. Random move only needed one success, so now it's happy and we can kind of keep traversing the tree. Alternately, let's say we went down to random move and we're like, is it going to hit into a wall? Sorry, it is. This is a failure. Then we can fail out as well. And random move can go like, oh, the whole left action failed. Now I'm going to pick another random choice. And it allows us to kind of proceed through. So this is a random move snake formally documented in a decision tree. I don't know. Do you think I've covered this? Is there any holes here?
I love this, by the way. This, like, I have zero real idea how to, like, start planning out strategy within Battlesnake. I'm like, okay, I want to survive, but this is that next logical step after I want to survive. So now let's figure out how to get there. So I'm very excited that we're actually going to, like, map this out and see what it looks like. I'm very excited.
Totally. So, I mean, this is the diagram. So these are the pieces we have: selector nodes, sequence nodes for like controlling the flow. And then we just need to kind of come up with our conditions that we're going to check or actions that we're going to take. And like in traditional game AI, like there was like a great example I read, which was talking about like an NPC trying to open a door. And that's an action, right? Open door. And maybe open failed. So the decision tree was expanded to be like smash door down, right? And then it gave it like branching options of actions as well. So there's like lots of things you can do here. Yeah.
Things have really devolved in chat right now. we are way far back, but I do think that whatever we do today, it has to start by going right.
Oh, for sure. Right. I mean, it's our snake. We can make it behave how we choose, how we see fit. We're the controllers. We build the machine. It'll be fine. Some other tools that we have at our disposal, there are a node that's called a decorator. So if you're looking at formal documentation or formal libraries that use decision trees, decorators are a control node, but they only ever have one child. So they're usually things like a negation. So like maybe you have a check, like instead of saying no wall, I wrote this like a very deliberate way, but I could say wall, and wall would be like, yes, there's a wall. And I might want to invert it to be like, yes, there's a wall, but it's not safe. So return fail. So there's like inverters. And you can also do interesting things with decorators to like repeat things or use it as a timer, but that's kind of getting into the nitty gritty of like your code control flow. So they exist. Decorators are a thing. I'll tell you that. But I think we're probably gonna, I don't know if we're gonna need that for this role. So I'm gonna switch over because I feel like if we're gonna dive into constrictor mode, I feel like we need to study the game. Yeah. Okay, let me just swap over here.
Oh, we're gonna watch some games, everybody. Deep Learning has taken a shift. We're going to watch some games.
Yeah,
what excitement.
Who are we? Are we like Curtis and Eileen now? Are we the same as them?
I feel like we don't yet have nicknames though, so
that's true. Ooh. Okay, so
I think I'm in Constrictor. Can you find? Can you see? Like I see, there's a recent game with. Oh, Toby, number 12 right now.
Oh yeah,
number 12. I actually topped the top 10.
You both need Curtis hoodies. I have my own hoodie, but it has my name on it. Are you wearing yours right now?
I am 100%. This is my new like cozy evening hoodie. Also, if you don't have this hoodie, this is I've only ever had one hoodie that I enjoyed more than this hoodie. And now that hoodie is dead to me. So
yeah. Oh man, showing games is pressure. Are you giving away prizes? I'm not prepared for this. Wow, casting is hard.
So I'm willing to say, at risk of like making Brad mad at some point, that we can do a prize, but I'm not sure what we would do a prize for. So that's the question mark.
If you've got an idea on how we can gamify deep learning, please bring it up in a chat, either Twitch chat or in Discord. So sweet. So okay, let's take a look at Toby. Let's see what the gaming is, because my feeling is that constrictor is neglected. I feel like there's a lot of room for improvement here, and we can be the ones to bring that change. So here we go. Zero. Which game do you want to watch here?
I was going to say, which game should we watch? The one where I live. They're all exactly the same. So, I mean, it's really up to you.
Okay, so here we go. So we have our hero, Toby Flendersnake, and Snack Nessagrav Leia. Okay. And Guacamole. So let's...
Are you telling me that at some point in Battlesnake, I have taken on Netagraph and won? That brings me such joy. You are all welcome, everybody.
Okay, let's run this game. Okay, this goes really quickly. Okay, so we got to step through this. This is like, whoops.
There's no decision.
Oh man.
There is actually a decision tree here. There is. The decision is if there's a wall, and that's it.
Okay, let's go back to starting positions here. So let's talk about this. So this is interesting. So the starting positions on the Battlesnake board, these are all possibilities. We've got a 4 Battlesnake game here. And just looking at this board, not even thinking about what actually happens here, but what do you think is a strategy for constrictor? We know there's no food on the board. You're growing every turn, so you don't have to worry about eating. You're not going to starve out. But everybody else is going to be hanging out. Oh, Nessagrav is thanks for pointing out. Your victory is short 1 here, Andrew.
Hey, it's all right. Listen, I have survived this long without anybody knowing who Toby belonged to. So
yeah. So I've always been a fan. I was thinking about this a little bit, and I've always thought if you've got a 4 snake game, you want to corner off, or 2 snakes, 2 Battlesnake game, you want to corner off that proportion of the board for yourself, possibly as soon as possible. And I'm thinking back to my old university days where we would run LAN parties and play Armageddon in my misspent youth. And so that's definitely a thing you want to do. You want to carve aside a little bit of space for yourself. So taking a look here, stepping through this, going to the middle, I don't know. I mean, maybe it's too early. It feels a little dangerous. I don't know. And then we've got, what do we have? We have Nessagrav and we have Snack turning away from each other. Guacamole is just plowing ahead, and your Toby is chasing the border, which is interesting.
That's a good word for it. There's very little strategy in this.
Yeah, I'm not sure. I don't know. It seems, I mean, it's not, I'm saying it's interesting because I haven't really thought about it yet, but by hitting the wall right away, and because everybody else is going in the other direction, you have a path for yourself, right?
I mean, this is a thing, but there's only a certain number of game modes that this works for. I do not do well when there is danger sauce. I just don't.
No, that's okay. But this is all right. Maybe Toby's calling is constrictor mode. It's okay to be a snake with a specialization, I think.
Let's say that it's a specialization.
Okay, cool. So what else we got here going here? So Guacamole's deking around the end of Toby's tail here. We've got Snack looping back. Nessagrav has a lot of space here. I feel right now on this board, Nessagrav is doing the best. This looks safest. You've got space to grow and move here. So this is interesting too. I would think so. Nessagrav's deking down here. But what about going up to the edge, right? There's space left here for Guacamole to move into. I don't know. That's just, my thought. I feel you want to cut off those edges,
But I find that if you look in all of these games, any ones where Toby ever wins, I don't know if it's just the way that the snakes that it's competing against are programmed to run, but they always all almost fundamentally avoid the edge.
Yeah, which is interesting. And I get the impression that a lot of folks toss, just their main standard snake into Royale mode or Constrictor or whichever. And why not, right? You definitely should. It's fun. But yeah, today focusing on Constrictor, I feel hitting the edge and cutting off your opponents just becomes that much more important. So that's something I feel we should tuck away in the back of our heads, for while we're working on our tree. Okay, I mean, Nesograph cut off Guacamole. Guacamole's doomed here, right? Like, as soon as Guacamole entered that spot, that was trouble. But they didn't have much choice. And what's even happening? Just sort of watching Sneck and Toby playing over here. Like, this is interesting as well, because like head-on-head collisions are a no-go. Everyone's the same length, so you want to avoid that. So I suspect Sneck has done the only thing it can do, which just shows why Toby's edge surfing is working so well. And then what's happening? What? Oh, poor Nez. Oh, there must have been a timeout or something. You can tell I'm unpracticed at this. Oh, what happened? What? Yeah, that latency just plummeted. So something just went south there. And then moving forward, yeah, at this point, Toby has completely cut off. Well, not completely. He can still go up, moving forward, looping around. Yeah, you're just edge dancing. Wow, that's cool. Is that on purpose?
Let's say it is. It's mostly because I decided to teach myself Python with Battlesnake, and this was one of the only strats that I could fully understand. Everybody uses really complex strategies, and like this one was pretty simple to figure out. So, so no.
And seeing this error here with Snag, I mean, this makes me think it's a standard snake, and it's like expecting the tail to move, and it's not going to move. Yeah. That's what it makes me think of. But like, okay, this is interesting. So here's a good Toby game. All right, so let's pop back into the constrictor arena. Let's take a look. Like, even the top snakes, I think I noticed it doesn't seem very deliberate. That's kind of the impression I'm getting right now. So here we've got Exploradora, Hardy Hybrid, Pruzy 2, and Sneaky Snake again. Yeah, so I don't know. I find this kind of interesting. So
yeah, I feel like you're right. People aren't programming for constrictor. Like they're just throwing random snakes, and then they happen to do well.
Yeah.
But who's on the board right now? So like, are people that are on like the top of the board? Are they also on the top of other boards?
There are some of the like Sneaky Snake and Pruzy and stuff. Yeah, they tend to be. Mm-hmm. So this is interesting. So once again, Battlesnake's moving towards the middle, a little bit of a jog, and then I don't know. I mean, it's tough. Like with everyone going kind of into the same zone, you're trying to figure out where you want to get your space. But like even here, no, I think I agree with this move for Constrictor. So just looking at Exploradora and Hardy turning away from each other, like it's the head-on-head collision is too dangerous. But this allows them to both start moving forward. Oh, Smallsco saying Hardy doesn't use a Constrictor-specific heuristic yet. Yeah. But to have pluggable heuristics, nice. Coding for the future. I love it. Just like maybe you can implement our decision tree. Let us know how it goes. So, okay. So I think where Hardy, if like deep analyzing every move here, I think, well, maybe like you want to start filling your space, right? So maybe curling in and then trying to loop around the edge. Yeah, this is interesting. Like right here, just looking at Exploradora, like I think not filling that last square is a bit of an error. Like you've lost it essentially. Like it's unreachable now by any other snake, and you might need it. So I feel like you really got to fill there. I don't know if you agree, Andrew, or disagree there.
I agree.
Shout if you want me to focus on a snake here if you're seeing something I'm not. Ditto here with Sneaky Snake, right? Like, I don't think when they had to make that turning decision, there was no reason not to go to the edge. And it just gives you that like extra couple squares of space. And then moving through the game, I like what Hardy's doing, like looping back. I think that's pretty good. Like your fill will probably find that the area below is bigger than the area above. So you might want to maybe have turned right instead of left there, but it's a tough call. There's also Sneaky and Exploradora kind of filling, and then the head-on collision. So this is the other interesting thing that I think is kind of complicated about Constrictor mode is when opponents are eliminated, and then all of a sudden that opens up the board, right?
It's true, and which is why I think that there is a really cool decision tree to come out of building for Constrictor, which is why we're doing this.
For sure. And then even here, this is perfect. So sneaky, like this is the cutoff. This is the kill move in Constrictor, right? It's not going for that head on or like that fun thing we see the top tier snakes where they're doing the tail chase of their opponent until they're able to inject in, like those beautiful, like, I don't know, is that like a Cobra Strike move? I don't know. But in Constrictor, it's about like closing off that box and then leaving your opponent nowhere to go. So this is, but yeah. And then a little bit of flair. That's a flare end. You have to agree, hey?
That is definitely a flare end. That's cold. That's cold.
Cool. Awesome. So have I watched some of these games? What are you thinking, Andrew? Like, what are some of the things we want to like try and sketch out, maybe a strategy or two?
So this is the thing, and I'm interested to do this because every time that I watch a game, I'm always just so impressed by the strategies, but I never know how they get there. So code aside, like even looking at how Sneaky Snake pulled this off, there's so many small pieces in there. Like what I love about what we're going to do is actually going in and like examining some of like just little things that they've done to see where those decisions are at. Like, I think that's such a cool piece is that I'm not seeing strategy in here. I'm just seeing really cool things. And I'm interested to go back and see like, okay, so he did this. What was the decision tree that forced him to do this? And I think that's the interesting piece about doing this for me is like just diving in and figuring out what the logic is and then trying to recreate it some other way.
For sure. Nice. Yeah. So, and feel free, chat, if you've got like, I have one idea and maybe I'm being naive. I'll admit that, but I kind of feel like, with a four Battlesnake game or a 2 Battlesnake game, depending on how you want to optimize. But I feel like 4 tends to be pretty common, is like based on your starting position, go like try to like beeline it to a place that will help you bisect the board, essentially. I feel like, and that's something we can do in a decision tree as well, is we can start with that intention and we can build nodes that are like constantly checking in, being like, is this working? Like, did someone cut me off? Is this strategy over? And we can kind of like check in and like go through that and like draw it out. So like just using this game board as an example, actually, maybe we should switch over to, I've got some like board mock-ups. Yeah. Because
of how awesome you are. Okay, so I think we've got it up here now. I'm going to go over the menu screen. Oh, where are they hiding? Oh, there we go. All right. Let me zoom in here.
Can we embiggen?
We can definitely embiggen. We can and full screen in, and then we can embiggen. And
NH Kerrigan just gave a whole bunch of gift subs. You're a sweetheart. Thank you.
All right. So do we want to start on like our first game here?
Yeah, I'm just thinking. So like this is like, if you have a full board, if you have 8 snakes, battle snakes on the board, like these are all the possible starting positions. Got to make up for that PR you just sent. Oh, jeez. So, okay, can I draw on this too? Let's see. This is the excitement seeing of if we can collaboratively draw. But like if you're here, do we see this? Maybe? Oh, maybe not.
Hold on. No, this should work. Oh God, things have gone terribly awry. How do I? Oh, don't use a new browser that you don't know how it works when you're doing this. Oh, there we go. Okay. So wait, what are you trying to do?
I was trying to draw on the first one in the corner there. So like,
you should be able to draw on that. It should update.
Freehand. Yeah, start drawing. Okay, yeah. Let's see if we can see. Oh, I don't know if it's syncing. You might have to draw. But like you see the ones in like the middle row, essentially, if you want to like free draw there.
Wait, hold on. Where's our free draw? Oh, see, this is preparation for a show, everybody. This is preparation for a show. Where's our free draw feature?
If you click on the plus button.
This
In
one?
the top middle of the screen.
Oh, yeah. This is why you prepare, everybody. So these guys right here, right?
Yeah, and you click on the Start Drawing button on the right-hand side.
Yeah, we're all good. We are there. We've got the drawing.
Sweet. There we go. I was hoping I could draw on the screen too. Okay, well, this is good.
Oh,
If you know great tools for collaboratively working on behavior trees, let us know in the chat.
So, I mean, I've got another one that we can use, and I can get it set up in like 30 seconds, but I'm shocked that this doesn't actually work. I thought it was Oh, I guess you've just got to like refresh all the time.
Oh, that sounds lame. Let's not do that.
Okay, give me 1 second. So let's go, and I'm gonna pull up a different tool that will allow for us to do this, and it will allow for us to do it like super easily.
Yeah, that's okay. Here, how about let me share for a second. I'll just share like a dumb little window I've got, and I'll talk through with chat what I'm thinking here.
Okay, awesome.
See if I can get some opinions. So I'm kind of thinking like if you're in a starting position like here or here, you are in a perfect position to start like a bisect, right? So you can be like, okay, fresh game. I am at, what is it, coordinate system. Like this is 0 here. And this is the 10th square because it's a 11 by 11 board. And this is 0 and 10 over here. Drawing with a trackpad mouse. Thank you very much. I'll take applause later. So like if you're in the middle, I feel like you're at a perfect spot to just like cut across and really give some other Battlesnakes some trouble. And then once you've made it across the board, hopefully all the way to the edge, you can kind of either go up or down depending on how things are shaking out around you. That's kind of like my thought is a strategy. So we could start with our first what's the term? Our first selector or sequence node. Maybe this would be a sequence of strategies. So we have our root node is like game start, and our first strategy is like try to cut the board in half. And that could be our first sequence, and we'll keep trying that as long as our moves are succeeding. But until someone gets in our way or like something is causing it to fail, then we could like move on. So because a sequence selector, as long as you're getting successes, it'll keep operating on that branch. And then when it fails, you can like switch to another strategy in the sequence. So that's kind of like the way I'm thinking about this. So we could cut it in half. And I mean, what's nice about this, just to kind of undo, lost all my marks here, is like the same is true if you're here or here, right? It's just your direction is across this way. And then I feel like if you're looking at an 8 Battlesnake game, like these corners are going to need something else. that's another strategy, I think. But I think with 8 snakes or with like 4, like I feel like this is a viable start. Like we could start building that. And maybe if we draw out the rules, then we can start thinking about, well, how does this go wrong? Like what prevents you from getting all the way to the edge? And how do you make a decision? So that's kind of what I was thinking. Did you pick any of that up, Andrew?
All of it. I feel as though I am well prepared to be successful as we work to build this out. But I do have good news. I've got us our brilliant collaborative environment.
Heck yeah.
Set up and ready to go. And I'm just going to share my screen as I do this, actually. And this is like a digital whiteboard, which will make life easier. So let's go back into there and then do this thing and then do this other thing and then do this. Your application. Oh, Edge tab. There we go. And then we're going to want to go that one.
Hey.
All right, and there we go. And then I'm going to share this link with you so that you can get in here and do it too. Okay, awesome. So I'm just sharing it with you in the other place.
Yep.
And then we can I'm going to upload our image that I got from over here.
Sure. Oh, let's start building the tree. Hey, like let's start giving her. You know what I mean?
Yep.
Cool. All right. So, okay, can we draw squares here? This is what I want.
Yes, we absolutely can. Oh, there we go. And blank board. All right. So I got our board here too, and we're just going to lock it, and then we'll be good to go.
Okay.
Lock. Perfect. There we go. Okay, awesome. So we've got our board. Now we're zoomed in. I'm feeling better about this. And then we've got our draw feature too if we want to draw.
Okay. Oop. I don't think I'm quite getting the updates here. Oh, practice your tools, kids, before you live stream. That's
No, what are you talking about? This is part of the excitement
awesome.
and the journey.
So why don't you give it a go here, Andrew? So let's get like a blank section to work on. And let's start with like a root node, like a start.
Okay, awesome. So
start
over
drawing
here,
that tree.
Okay, so and we're gonna start with the same as we had before, right? So we're just gonna are we gonna choose random or are we gonna choose right?
I think let's just use a square, and I think you can use a text box. Let's just make this root like start, like an initialization. You need a root node.
Okay,
it doesn't do anything. It's just start.
Start. Okay, awesome. We got it.
Sweet. Awesome. And I would say like our first, so using the like terminology, our first like sequence node, so you can kind of like draw a new box connecting it. I think this is going to be our like bisect strategy. Is that a good name? Always right strategy. No. Root node should be right. Yeah.
Wait, sticky note. All right. There we go. All right. So, and then we're going to do our bisect strategy, right?
Yeah. So let's call this blank square bisect. I'm thinking.
Right. I love it. Oh, your tools, everybody. That's a good point. Shape. Where are you hiding? Oh my God. All right. Bisect.
Oh, there we go.
Did you get it working?
It's like it was just really slow to refresh, but now I see you doing stuff on my screen. Yeah.
All right. Awesome. That's a good sign.
Sweet. Okay. So I feel like first, like I feel like we can do a leaf right away because I'm thinking the bisect strategy is like only gonna work just to draw over here if you're like in one of these 4 locations. How does that sound to I feel like corners are just different, right?
Yeah, totally.
So I'm feeling like first move has got to be a leaf node. So I'm going to do a different shape for a leaf node. Let's give that a go. Well, let me do it. Whoops.
Yeah, you got it. It showed up down there.
Oh, weird. Okay. Mousing is funny. Yeah, let's pop one of those up. Oh man, thank you. And I feel like this is like a decision. Oh, the text is tiny. Like, what is this? Like, is center position. So those coordinates are like one of, what is that? That's going to be like on the x-axis. That's going to be like, what is that? 0, 1, 2, 3, 4, 5. Right.
Yeah.
So it's like 5, 1. And then like for the one on the left, that's like, what is it? 2, 5, I guess. Or sorry, 1, 5 again.
1, 5.
Thinking it's hard.
and then
9, 5, and then at the top it's
5, 9.
No, it's more than that. Yeah, 5, 9, 5, 9. So like if you're in one of those starting positions, like that's your first like leaf node check. And if you're not any of those, can we group these together?
Yeah.
Group. Yeah. This is like your first check. So like if we want these to go in sequence, like if that fails, our bisect, like we're doing something else. But like this is our first check. So let's say you're in one of those starting positions. Can we join these? Yeah, we can. Oh yeah, look at that line.
Boom! Killed it. There we go. See, we figured it out.
Yeah. Okay, so that's like the first thing. And then do we have an action mode? I mean, early game, let's use a different shape for an action leaf. Come on. Here we go. I guess go towards the center. Is it that simple? Yeah, because no matter which one you are, you're going to want to go to the far edge.
Yeah, exactly.
So this is go to far edge. And this is like, the reason I've given this a different shape is it's an action. So if you think about the commands that are being run up the tree, the way you kind of think about it is the leaf node is going to say like success, fail right away. Like it's a conditional check, but go to edge and like maybe go to edge isn't quite an action, but like part of go to edge is going to involve making the move. So doing the command like left, right, or up or down. And once again, because we're drawing diagrams, it sounds like an implementation detail to me, but we know how to go left, right, up, and down, right? We're Battlesnake, aficionados. We know what's happening here. So going to the edge would be the next action. And then at some point, it's going to potentially, like either you're going to meet the edge, right? Or you're going to run into a problem. So I guess that's where we have to sort of decide what's going to happen. So if these are a sequence where they all must succeed, let's talk about the success case first. So let's pretend you are...
sneaky at the top or sneaky on the side?
Like, yeah, let's say you're like this one right here on the left.
We'll call you Left Snake.
Lefty. And let's say you've managed to successfully, like you're going through your decision tree and you're like, okay, my start position was on one of these like valid locations. I continue to go right, always right, go right. I've moved through, I'm moving through, like no one's in my way. There's nothing preventing me. Like we're using the little move check. We're like, is it a wall? Am I hitting myself? Is there someone else? Okay, like go right. We're continuing to use that little decision tree submodule to control our individual movements. And then like, let's say you've managed to successfully all the way get to the edge. Then what?
Go right. Go right. Go right.
Always right. Root node should be right.
I feel like that's but it's valid, right? Because you're gonna need to either go like up or down. You're gonna need to go left or right. And so I feel like it does actually make sense to just continue that.
Yeah, for sure. Well, we can't keep going right. That's the wall, man. That's game over.
Oh, sorry. I meant right from the direction. So down. Sorry. Yes.
Oh, you're like
so. Yes, sorry.
I am person moding this.
I am imagining that I have become Lefty the Snake and I am about to go right. So everything is right in my mind right now. Even if we're going up, which will eventually be the next thing that we'll need to do. It will be right.
Nessagraph saying go up if most snakes are downstairs. I think that's like totally... I 100% agree with you. Can't be wrong if you're always right. Yes.
What's up? Yes, Hexagon.
I feel like, okay, I want one of two things now out of Brad and Joe coding badly on Saturday. So initially what I wanted to build this decision tree and be like, so now Brad and Joe, you're going to write the code because that's your job on this Twitch stream is you're going to now write this decision tree code for us. But I've changed my mind. I would also accept if you built Righty McWriterson, the right turning snake. I'm also good with that.
There are things, or both, you've got time.
You've got time. I don't think like Righty's going to be too hard, but it does have to shout what what Hexagon is suggesting here, which is that you can't be wrong if you're always right. Yeah.
I do love. Thank you. By the way, these are like this is why I think we do these live streams is both to teach you things, but also to learn things about what our community is really after. And Ryderson seems to be. We tried to get Lefty the Snake, and nobody wanted Lefty the Snake.
Yeah, Righty McWriterson. That's the way. That's how I like when I write unit tests. I'll like go through themes, but when I'm really feeling like creatively deprived, it's just Testy McTesterson. That's like my default name. But like, yeah,
that is actually, just so you know, that is also my default name. I created a snake called Testy McTesterson. But did not survive. Yeah. Anyways, so we've got our tree started.
Yeah, and buried in all of the nonsense was definitely the suggestion is like, let's look how many Battlesnakes are above us, how many Battlesnakes are below us, and just go to whichever one is less. So I feel like we need another like I think we want a selector node this time because we would want one of those to succeed. I'm just trying to think about what the correct notation would be. This might be a little awkward. Learning a proper, it's like when you're drawing like database schema. I like always do that wrong too. I just get so tired of the correct notations so quickly. Your default test stake name isn't foo? No, I like a good long name.
This is a struggle that I have never experienced, but it does not sound like something I want to experience either. So
yeah. But yeah, so we're probably going to get sloppy with how we use these symbols. But I feel like this is a selector. We want like one of the two to succeed, and the condition is like above how many snakes, like below how many snakes, so, like which one is more?
Hold on, maybe we should, okay, so we are getting sloppy, but maybe we should actually start to like track this. So which are each of these right now? Just so that like if people are on the view, like what
that's
so like do a legend.
Yeah. Oh, that's a good idea. So that is a condition leaf node.
Leaf node.
Yeah.
Okay, and then you've got your square down there already. Also, it's weird that these are not enjoying letting you write in them, but whatever.
Yeah, they're a little bit awkward, hey?
It is the technology that I have now thrown us into because the other technology I chose did not work. So we're just going to ignore that happened. Okay. Okay, so condition leaf node, and then we've got our
the
leaf node.
The hexagon is an action leaf node, yeah.
Okay, so we've got that for one, and then we've got our action leaf node for our next one. Oh, there we go, action leaf node. Now you're working. Okay, so now we've got a little bit of a legend for everybody, just in case you're wondering what the heck is going on.
Nice.
And then is this going to be, oh, there we go.
Okay, so I'm seeing if I can do this. We've got more snakes up. So this is like another condition check. And I feel like I need its partner, more snakes down. And like, oh, but we still need to tie this to like an up or a down. Just trying to think about that. Like snakes up. Oh yeah, no. I think so. Like, I'm going to change this. I'm going to say up safe, fewer snakes, because we want one of these to succeed. So I think that's the way to kind of frame the question. And then like down safe. Or like you'll have to invert this depending on like which coordinate, whether you're like in the middle, in the upper quadrant or lower. But like we'll worry about transposing this later. Suffice to say, if we draw this decision tree out using the language for this like left center snake, you can like rotate it to cover all of the different sides. So either up safe or down is safe. And it's whichever, safe in this case is going to be like whichever has fewer like battle snakes. And one of those is going to return success, and that will be the decision we move, or that will be the direction we move in. Whoops. Get another connector here. Sweet. So this is our tree so far, is we're going through our bisect. In order for our bisect strategy to work, first we have to verify that we're in one of the like positions that this strategy requires for the starting position. We then try to proceed to the far edge, and assuming that that succeeds, our next step is to choose whether or not we go up or down or left or right or whatever it is, depending on which edge you've hit. And the way we're going to determine which choice we're going to take is based on like which side of the board has more or fewer snakes. And this is a good time to do the check, because depending on how crowded the board is, like there might have been some eliminations already at this point. That's fantastic. So at this point, let's say we've gone up. What's our next move for our bisect? What are some other things we could check? Like, what would you do in this situation? Andrew, what do you think here?
So
Channel Toby.
I was gonna say Toby, like I would honestly follow that, but at the same time, we're trying to make sure that we're cutting this off for anybody else. So I would start to sweep the board. And I've seen this strategy used where it's just sort of starting to snake up, for pardon the term, but to like snake up the board, and sort of go back to where to back to where he came from to the other edge. But I don't know if that would actually be effective.
Move right. I'm sorry, and Kerrigan, like, how did we not? Obviously, we're doing this wrong. Yeah, move right. When in doubt, move right. Ready McRiderson's true passion. Yeah, I think there's a couple of options. I think at this point there's like some more things I want to check because we have some decisions. So like the perfect, beautiful bisect game is you've reached the edge. Your opponent's like, if you're going up, say, like let's say you've chosen that, in the ideal situation, you are the only Battlesnake in that upper half. Like
Totally.
That's like success. So you've got like, if you can just start like filling like this, you know?
Yeah.
Ideally. So that would be like one thing I'd check is like if I'm the only snake on this board, and maybe that's our next choice because like technically there's still, can I change the color? Yeah. I'm going to call this the danger path right here. Like someone could sneak in that corner, but maybe you start filling because even if someone sneaks in on the edge, like trying to use as much space as you have on the right as possible.
But what I'm saying is, what if you did, like, what if you went back and maybe I'm just like, maybe, so you're talking about going up this way. I'm talking about instead of doing that, going, let me change the ink color. I'm saying, so you're going to go up and then just start going this way so you can block off anybody from going. I mean, I guess there's a chance that they're going to get in there, but then you just start sweeping up like this.
Yeah. I know. I like that. I like that strategy a lot.
Because then the thing that I like about that is that you're then, yeah, there's still a chance, but you've only got, if you do it this way, there's much more of a chance. Whereas 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like 10 moves as long as you can beat them there.
I like that, especially if it's like a 1v1 game, because once you've bisected it in this, like all you have to do is not like lose a square at this point. Like you just need that one square. Totally. So cutting off that entranceway to prevent shenanigans is interesting. I guess the only motivation I have for trying to do a fill this way is if you needed to escape out. That's something.
Yeah, well, that's what I was just thinking. Like, it also is gonna take you a lot longer. Like, there's a lot that can happen in the amount of time that it takes you to block that entrance versus what you can accomplish if you're doing the opposite fill. So I definitely agree with you there.
Totally. This is interesting. This is like the nitty gritty. Like I'm liking drawing this on paper and just thinking about it. Okay. So I'm willing to try a decision tree where our first choice is to like now basically backtrack. So constrictor mode, cutting someone off, it's permanent. I know, right? Like that's kind of the whole thing is like when you cut someone off and it's permanent, like that's the power of constrictor mode. And I feel like this is so neglected. I would love to see constrictor mode be in another tournament again, maybe summer or fall or something like that, so that we can focus on the meta of this game, which is different. It's different from the other game modes. So true, Extagon, you speak truth. Okay, so let's get a new node here. So you've chosen the direction you go up. And so I think our next action, and we're going to need another kind of sequence. Like this bisect is like all very sequency at this point. Like everything has to succeed. What we've written so far, we're doing the success path only. Yeah. So let's get another sequence mode. So choose direction has succeeded. And now we're moving on to the next. Oops, man, I keep drawing the squares in one place and they appear somewhere else. Here we go. So now let's call this like the back sweep on the freeway, cutting someone off.
There we go. I like it.
Yeah.
I have actually seen this strategy employed by like a new dev. Like this, it's all their snake does is wherever they are, it doesn't hit the wall and then it just back sweeps. But I don't think they're in Constrictor. Like that was in Spring League. I watched a game.
Gotcha. Nice. So back sweep to other edge. I mean, we can use the same kind of checks. And maybe we just do this regardless of how many, like we're going to need to, this tree, I chose partially I chose constrictor mode because I thought it would be easier without the food, but like, holy smokes, I'm just thinking in my head, like, well, what if there's another Battlesnake up there with you? And like, what are they doing? I mean, maybe, I guess I'm hoping a lot that if someone is trapped up there with you, then they've turned themselves into a corner and freed up some space.
To be honest with you, I'm thinking now, like, as we talked about, it's almost like what you would really have wanted to do, depending on the side that you're on, would be to do, let me just get another color here, would almost be to do like a tail chase and then...
Oh, like loop out? Oh, that's interesting. So like, oh, I like where you're going with this. So I don't want back sweep to other edge. I need another evaluation. Like, you have to choose direction again. Choose direction at like closing point. Yes. Yes. So you have to choose the tail if I'm moving right. Righty McRiderson, Brad and Joe coding badly, make Righty McRiderson, you know, make it happen. It's what the people want. So yeah, we need another choosing direction. And it's actually the same subs tree for leaf conditional node checks. Oops, I got almost all the lines. So yeah, and then we can choose the same thing again. So that's an interesting one, because then if you are trapped up there with another Battlesnake, but maybe the bottom part of the board has freed up, that gives you way more options.
Oh, yeah, that allows you to escape, right? That's true. Ooh, I like that.
Yeah. I think that's interesting. Oh, that's cool. And I feel like, so as you draw this, like I'm starting to see how this is like functions and subunits and components. So,
but also it's interesting too, because this same works for everybody, right? Like it's all opposite edge. And I'm just looking like every single one of the, even corner snakes, to be honest with you, like this actually would even work for the corner snakes, because whatever you're doing, you're able to bisect.
Yeah. I think it's just less likely for a corner snake.
Yeah, I agree.
Yeah. Some good advice in chat: to develop a good snake, start simple, like 1v1, because if you try to code all the possibilities, you will never release a snake. Yeah. You just start getting overwhelmed. Hey. And then, yeah, start simple and never continue. I think that's why I like this mode for thinking about, like, we haven't written a single line of code yet, but by talking through the possibilities and like drawing this decision tree diagram, we're starting to see the patterns and like where we can reuse stuff. Because I feel like there is I feel like there's a couple of like little like bump functions you can do to like slightly fix yourself or get like back on course. So what I mean by that, if I just kind of erase. Oh, won't let me erase.
No, you should hold on. I'm facilitating. Do you want to erase what's been done so far?
Yeah, on the little snake board there. Yeah. Sweet. Yeah. So like, let's say you started going down this path and let's say someone else has come in. Let's say there was like one other snake in the starting position. Maybe like got up in your space and then deked down again. And I'm pretty sure we actually saw a Battlesnake in one of the games we watched kind of essentially do this move, right? And I feel like there's a couple of like little submodules we could create for ourselves where you're just like, this is fine. I'll just go around, like, you know what I mean? And like continue on with my journey. Like, I feel like there's like little helper logics we can put in, and that becomes a little decision tree that you build, and then you can kind of like plunk in wherever you need it. Nice. Question from Jeffrey Pert, relatively new to the community. Welcome to the community. Wondering if there's a good resource with sample implementations of simple decision trees. So I think this is what's interesting is I don't know of any Battlesnakes out there that have built a decision tree deliberately. What I've definitely seen is a lot of Battlesnakes that have done, we kind of call them like rule-based snakes is the term we use a lot, where you just sort of start moving and you just start building rules like, oh, if I'm in this position, I want to behave like this. And you just keep tacking on more and more rules. And I think by accident, that is logically a it's logically a decision tree, but it's not like deliberately implemented or using the functionality. So as a result, it gets kind of like tangled. It's probably more like a finite state machine at that point. Which is interesting because like when reading about decision trees, one of the things that comes up a lot is like, well, decision trees are very similar to a finite state machine. A finite state machine has states as the nodes rather than these like decision points that we're building, but they're very similar. But a finite state machine can get itself into weird states where they like, you can like loop, like have loop behavior that you don't really intend. And like, as you're transitioning through states. So that's why in game AI, a behavior tree is preferred because it's easier to draw out. It's stricter, like these rules for how we build it give us some constraints that give us stability and like confidence that what's happening is what we meant to happen. And then it's also way easier to debug. If you've ever had to debug a finite state machine, you get into these like really janky situations where it's hard to reason about it as a human. And like something my partner says a lot, like, is if you write like really, really smart, brilliant code, then like by definition, like it's too good for you to be able to debug it, right? Like, like if you have the code that you wrote on your best day, then on your average day, you're just like not smart enough to debug it. So I always like writing code as simple as possible and easy to reason about, which is why I'm kind of attracted to this behavior tree. So this is like new territory. Having said all that, though, if you are looking for resources for Battlesnake work, I feel like we have to do a call out to Hexagon's.
Awesome Battlesnake!
Yeah, I'm just gonna.
Do you have it up?
Yeah, this is a fantastic resource for all sorts of Battlesnake strategies and resources and like different open source Battlesnakes that are out there. So shout out to Hexagon's awesome list. That is an excellent place to grab stuff.
Side note, also a good place to grab stuff if you are new to the community and you're just getting started. Check out the Battlesnake just docs, because there's some improvements that have popped up in there if you're just getting started. It's not logic wise, but there's some good things that are in there that are worth checking out.
Mm-hmm. Mm-hmm. Very cool. All right. Yeah, check out the Discord.
Yeah, and if you don't know where our Discord is, just go to play.battlesnake.com/Discord. I put it in the chat. There you go. That'll get you there. So, ooh, what's this? What's this quote from Alter Saddle? Am I going to regret putting this up on the screen?
I don't think so. I think that's safe. Alter Saddle's pretty trustworthy. Sweet. Yeah.
Awesome.
Oh yeah, debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are by definition not smart enough to debug it. So that's the true and honest quote by Brian Kerrigan, who is a famous computer scientist who worked at Bell Labs. Blam. Nice. Thank you for that, Alter Saddle. Okay, so I feel like we can reach at least a kind of success point on our bisect tree going through this exercise. I will admit this is harder than I thought it would be.
But this is good. I mean, to be honest with you, what I like about this is, as a non-computer scientist, this is making a lot of those concepts that are eventually going to be programmed so much easier to do. Like, I can actually look at the way the Toby Snake works now from this perspective, which I think would help me to now build the branches off of that, which is really important, because I've been stuck on, okay, so he gets to the edge and he keeps going around the edge. What now? Where's the decision-making process in there? Absolutely, for sure. Yes. ANSI KNR first programming book, Jeffrey Pearl. Yeah. No, that's a classic. That's like, yes, that's a good book. I would love, I'm kind of interested in doing like a deep learning book club thing, but I haven't had enough time to read a whole book and then do a book report. I don't know. Maybe, is that a deep learning thing you folks would be interested in? Book report review. KNRC might be like, that might be a little thick, but maybe we could do something smaller. Never read a programming book? They're fun. I don't know. Reading textbooks as an adult when you don't have to is way more fun than when you're a student and you have to.
Sweet. Okay. All right. So with our bisect success, so here's the thing. Noticing in constrictor mode that it appears most battle snakes aren't really taking into account the fact that it's constrictor mode, that like they're not really doing anything special beyond what they do in standard. I already feel like by being just a little bit more deliberate in our approach, that this algorithm that we're sketching out could have a degree of success. So right now, if we're in a starting position, that's number one. You have to start there. We have nothing for you if you're not in one of our like 4 selected starting positions. But I feel like a Battlesnake has a pretty good chance. Our first choice is to go to the far edge, so we'll be moving forward. We haven't drawn out a tree, but I feel like there's a little like deking maneuver subroutine we could write to handle this kind of situation, so we don't completely lose our strategy as we're trying to bisect the board. And then we chose direction. So once we reach the edge successfully, hoping that we do, we've chosen to go up or down, or in the like branch, take our branching path based on how many battle snakes are in each half of the board. And then we've decided that our next strategy is to try to loop back. So the ambitious like fill your half of the board. But that gives us a lot of flexibility. So as we're filling, I mean, in the most idealized situation, one of the things we're going to want to try is to just keep filling back and forth. Yeah?
Yeah, I think so.
Yeah, cool. So I feel for this, trying to like remember the notation, is I feel like if we've done those 2 things successfully, like we've cut off, we have successfully bisected, then the next option is, and I'm going to say this is going to be a selector. So only one of these has to succeed, because I think we would have to define a couple of fill strategies, which, oh, come on, text.
I'm going to make all these bigger.
Like you may have to do slightly different things, but like we're going to try to fill the board, and how exactly we do that is going to change. And we just need one of them to succeed. So like this is a fill strategy and this is a selector. So only one of these has to succeed. So if I, pop this over here, trees get big. Sweet. Oh, I'm running out of space on the board.
Hold on. I can fix this. Boom! Board just got bigger. Look at that. Our tree has got space.
Nice. Yeah, definitely want this. Oh, come on. There we go. So our first fill strategy selector, like ideally, if you're on your victory lap with your Battlesnake, you just continue the like alternating back and forth.
You just called it a victory lap.
Victory lap. I don't want this to be a selector. I'm going to make this an action. Sorry. What's our action leaf node is this. So that's like your action. That's what you're doing is, oh, come on. Whoop.
Oh, the technology.
There we go. So like, just like back and forth sweep, right? So that's an action you would try. And with the decision tree, logic, what would happen is like your Battlesnake would be just doing this and would be like sweeping back and forth. And if at any point it was unable to continue that behavior, like let's say there was one Battlesnake in that same territory and you finally confronted it, it would be like running, and then it would either reach the end and the game would be over and you have success, or it would return a failure. So at that point we could choose another strategy for filling the space, as it were, which I think would also be another action. So back and forth sweep, like big sweeping, is a possibility. If you have another Battlesnake in the space, though, you might have more success with an up and down. Does that kind of make sense? Like there's the longer axes that you're trying to fill versus the shorter axes.
And that's the thing, right? Is like, I feel like that's where the difference becomes between those 2 strategies. Because you're right. If there's somebody else in there, you can't take the time to try and cut them off, and it's going to actually work against you anyways. It's better to cut off their space. So I'm with you 100%.
Yeah, I feel like that's the other option. Yeah, burger fill versus hot dog fill. Yes, I love that. Isn't that one of those things that like tell you where you grew up? Is like when you talk about folding paper, like hot dog versus hamburger style. I definitely did that as a kid.
This is my favorite. Well, I already said that Brad and Joe coding badly, controlling a snake with their face was their favorite stream, but Burger Phil versus Hot Dog Phil just made this my favorite Battlesnake stream. So thank you, Alter Saddle.
Yeah, there you go. Perfect. So, okay, so this gives us two strategies. So, I mean, both back and forth, Hamburger Phil versus Hot Dog Phil versus Hamburger Phil is like really efficient use of space. But let's say there's another Battlesnake in there with you and they're just like really not having your barbecue fantasy. I think I'm going to cop out and just say that your action is to revert to random move. Yeah?
Or right, that you know that in about 2 seconds
somebody's going to
throw right.
Go right.
There it is.
This is our Battlesnake and it does what we tell it to. Okay. I like this. I like this a lot. Sweet. So, I mean, we're still missing stuff here, but I think this is a pretty complete happy path at least. And like we just, let's not be negative. Let's not even bother to code the sad path. Like we'll just try our best. And the way this decision tree is written is that in the event that any of these conditions fail, so like reading this, we go to bisect. If we're in a center position, then we'll try to go to the far edge. If we succeed in reaching the far edge, we'll do our up or down evaluation. But if at any point this fails, like let's say we don't get to the edge, or like let's just say we're in the corner, then what's going to happen is because this bisect required, it was a sequence selector object. So in a sequence, all of them needed to succeed. It's going to fail, which means we just need one other node, which is an action leaf node as well. Let's just make sure. Oh no, I'm screwing up your beautiful legend here. But obviously action leaf node is to go right. Like we just need one failure state here. So if everything goes south, go right. And that's what's going to happen here. Come on, draw a line. Oh, connect. Yes, here we go. So here's our beautiful connectors. And even if we get very far in our path and we're using our fill strategy, we've successfully bisected the board and now we're just using our space. Now the hot dog and the hamburger icons. Yes. Once we get down here, if that also goes south, we'll just go right. So I think this is good. I think this is solid. I think this is a Battlesnake I can get behind. Yeah. How you feeling?
I'm digging this. Like this is Righty McWriterson is definitely a snake that I feel needs to now be created.
Yeah, like this is a hybrid for sure. I'd say this is like a bisecting snake with a right strategy fallback.
Yeah, it definitely is. But Righty McWriterson just seems like such a good name.
Yeah. So now Joe and Brad have to code it. Yeah, obviously. This is what we're looking for. So challenge out there, Joe and Brad. Please build our bisecting constrictor mode decision tree snake. You're free to do it however you will. But hot tip, go right is a strategy embedded in it. So you might have to build go right first. That's my expert advice.
There we go. So I also saw in our other conversation that there is a potential for like a giveaway today that we could do. It would be a good end to the show. But I'm curious do we have a good idea for what a giveaway thing could be on our deep learning stream? Should we do a skill testing question perhaps?
That's a lot of pressure for me in the moment. Maybe a skill testing question? Yeah, okay. I mean, I tried to say this a lot. This is not when I'm teaching, I have patterns around repetition to help people remember things. So I don't know how well I did this, but there were two types of selector. So the square boxes, there are two types of selectors, and maybe the first person who's able to identify the two main selectors we use, that could be a giveaway. How does that sound?
Nice. I love that. All right. So in the chat, throw it in there. First one to be able to identify the two. And it just so happens that they are hidden away. Nobody can see them.
Oh, it's not on screen right now. Yeah, it was on my little like diagram at the beginning with my drawn tree of random moves.
Let's see. People are Googling right now.
The only selector was go right. Yeah.
There may be a winner from that. It's like people are like, I didn't realize that there was going to be homework at here.
Well, deep learning's not supposed to be homework. It's about the educational journey. Yeah.
There we go. Oh, I love it.
Everything else is just distract from the right strategy. I mean, I feel like this is fine. If no one can remember, Jeffrey is inarguably correct here.
It's true. And a new member of the community. It's that 10,000 lines of code.
Awesome.
There's a winner in here. All right, Jeffrey Pert, we got a gift card for you just for participating and as a welcome to the community as well. So we will throw that to you out in the community. And I just saw on our Discord that you're in there as well. So stay tuned for a nice DM on Discord from me in the next 24 hours. Congratulations. And I think we've got like one more show for sure. But in the chat, like, let us know if you like deep learning, if you're digging it. Let us know in the Discord chat that you want us to keep doing these, because we want to make things happen that you enjoy.
Yeah, we are happy to do a fun deep dive on any topic. Enjoy the learning journey together. Yeah. Do we have time for dumb questions about decision tree basics? I mean, you might get dumb answers. We'll see. I would not consider myself an expert, but maybe as a group we can try to get there. Yeah, give her a shot. Good intentions.
Also, welcome to the chat. Good intentions.
Yes.
We've led people down a very, very deep path. Wrong one. There we go. So question, what is a DAG?
So I'm trying to remember. So a DAG, I have heard it, but I was trying to remember, like, Wikipedia, help me here. So a DAG is a directed acyclic graph, so you're not allowed to do cycles. So I think technically, yes. There's the one thing I'm not sure about is in a directed acyclic graph, like you can have more than one parent. And I don't think that like a node could have more than one parent. And I don't think that's true in a decision tree. At least I haven't seen any examples of that. So not a true directed acyclic graph because of the parent relationship. I think all nodes only have one parent. So that would be the difference. Yeah. Does it count as acyclic if it always ends in move right? Is there a word for like a left graph? I don't know.
Lefty McGrafferson, I think, is probably as close as you're going to get.
Yeah. Yeah, that like having multiple parents for nodes adds like extra complication in your traversal as well. And part of the beauty, I think, of decision trees is this simplicity because you do have this relationship. So directed right graph, DRG. Yeah.
I like it.
It's like one branch to the right. Refuse to acknowledge that it's like a list or array. Just refuse.
Do you have any other questions? Good intentions? Anything else?
Thank you.
That was awesome. Yeah, thanks for throwing a question out. For anybody else that's on the stream that's maybe been sitting quietly waiting to ask a question, we are here to give you good answers from Wikipedia.
Mm-hmm. Awesome. That's definitely when I'm teaching, especially like new programmers, we always try to show that like everyone has to look stuff up. Maybe someone's just a few steps ahead of you. So that was fantastic. So too far out of my wheelhouse. That's all right. I hope you enjoyed this. I hope this gave everyone a little bit of taste about how trees work, and maybe even just give you a couple of ideas and tools about how to think about designing your snake. Coding is super fun. I won't deny that. But it's kind of interesting to take a step back and just be like, what could happen here? Like, what are the moves? What are my intentions? So I enjoyed graphing this out with you, Andrew. Thanks for awkwardly collaborating on drawing tools using mice to draw.
No, hey, listen, I dig this. This is my kind of coding. This is coding without having to code. I love the logic of it. So this is great. So Aurora, we kind of talked about it. Are we going to do the thing that we talked about? Should we like drop a hint for people about what our next deep learning is going to be about?
Yeah,
so So if you are a fan of Battlesnake, you're likely also a fan of the classic game that it is based on. And if you're interested in learning more about some different iterations that exist in the world of that game, then you should tune in 2 weeks' time, I think.
Yeah, I think let's take deep learning a little historical. I think that's the way I'm thinking about it. Yeah,
we're taking a historical deep dive. Also, we're going to play some awesome games. There will be emulators. There will be fun. There will be history. I'm going to see if I can find like a snake costume in the next 2 weeks. Has that been done? I feel like I've not been around the Battlesnake community long enough.
I've never seen that. I've never seen that. Andrew, if you buy a snake costume, I mean, basically, you could ask me any favor. I'd be really.
I was going to say, I think I'm going to try and expense that too. We'll see what happens. It's like, can I buy for deep learning? Can I buy a snake?
Yeah. Hexagon's quoted it. You've committed now. Someone clip this on Twitch. I don't want you deking Anna this the way Chris did. Chris claimed he'd eat a sock, and then I didn't see a sock get eaten, is what I'm saying. So, yeah.
Oh, Commodore 64, you're close, Jeffrey.
Yeah, we'll see how it goes.
We're going to do some cool things.
All right, well, we've got a little longer than we normally do with deep learning, but thank you everyone for joining us on this journey. Thank you for coping with us as we awkwardly draw in the software, but talking through the snake and giving us the perfect default strategy, which is when all else fails, go right. So thank you for joining us in Deep Learning. We'll hope you'll join us in 2 weeks' time for I think it'll be our last episode in Spring League, because then the tournaments will have been running. And finally, a thank you to our 2021 GitHub, our annual sponsors, GitHub, Replit, RBC, AWS, all of those fine organizations help us do what we do. And if you have any thoughts or desires out of Deep Learning, please pop that into Discord. And yeah, I feel like that covers it. Thank you all for joining us. It's been a delight.
Thanks, everybody. That was great. Have a great rest of your day, night, morning, whatever time it is for you. And we'll see you next time here on Deep Learning with Aurora and Andrew. Bye-bye.
Bye-bye.